In this video, we want to do a couple more examples on doing isotope problems. So the first one we want to do is one where we have an isotope. We have mass numbers, atomic numbers, charges, symbols, and we want to extract out of this isotopic designation all the information you see here. Because when you write out an isotope in its proper isotopic format and designation, all of this information you see down here is encoded in that. You just want to make sure you're able to extract that out. So let's go ahead and start extracting this information out. First thing we want to do is recognize in the upper left hand corner, that's where the mass number would go. So our mass number here is 44. So first off, it's just recognizing where the information is located. The mass number, upper left, that's going to be 44. In the lower left-hand corner, this is where the atomic number resides. So the atomic number is going to be 20. In the upper right-hand corner, that's where the charge is. So that's +2 or 2 plus. Doesn't matter how you write it, whether you write it +2 or 2 plus, doesn't matter. So these three we got just from recognizing which information goes in the specific position. To get out the protons, neutrons, and electrons, we have to do a little bit more work in terms of thinking about how these are related to each other. So let's start with the number of protons. So our protons here, our protons are going to be 20. How did we get at that 20? Well, we got at that 20 because we recognized protons and atomic number are the same thing. The number of protons is based upon what that atomic number is. That's literally the definition of it. So those are always going to have to match. Excuse me. Another thing that we're going to be able to figure out is the number of neutrons. And what we're going to see is that our number of neutrons is going to be 24 here. Well, how are we going to get 24 for these neutrons? Well, to get 24 for these neutrons, what we have to recognize is that the mass number is going to be the sum total of our protons and our neutrons. So these two combined have to give us that mass number. So my total mass is 44. 20 of it comes from the protons. Well, the rest of it has to come from the number of neutrons. These combined have to give you that mass number. The last piece is the number of electrons. So number of electrons, remember, we can figure this out from the charge, the number of protons, and the number of electrons. That's going to come from just kind of fixing this up to make this a little clear where we got the mass number from and how we figured out our protons and our neutrons. Our electrons are going to come from the relationship between the protons and the charge. The charge is +2. What is that +2 really telling us? Well, that +2 is telling us that I have 2 more positive charges than negative charges. Well, if protons are positive and electrons are negative, I better have 2 more protons than electrons. So 2 more protons than electrons means I better have 18 electrons such that I have more of these positive charges than I do of those negative charges. So that's how you're able to extract information out of this isotopic designation. And you're kind of doing that by using some definitions. Protons and atomic number are the same. Protons plus neutrons always have to give you that mass number. Your charge is based upon that relationship between the protons and the electrons. If it's positive, you have more protons. If it's negative, you have more electrons. Then the number tells you how many more of each you actually have. So what I want to do next is I want to do another problem with you. And this one is kind of the opposite of what we just did. So I'm going to erase part of what we have here to write out our new problem. So our new problem is going to be, we have 34 protons, 36 electrons, and our mass number is 80. So what we're going to do is, our task is, with this information already in place, we need to figure out the missing pieces. So we have to figure out how many neutrons we have, what the atomic number is, and what the charge is, as well as writing it correctly in that isotopic designation. So I'm going to leave in purple kind of what we had in terms of starting information, and what we had to figure out I'm going to write in red. So our first kind of step in this is, well, are there any definitions we can use really quickly? And there is. If I'm looking for the atomic number is the same as the number of protons. These need to be identical. So definition of the atomic number. So our atomic number needs to be 34. We can also figure out the charge pretty easily in this. I have 34 protons and 36 electrons. So if I think about protons being the positive charges and electrons being the negative charges, I have 2 more electrons than protons. So I better have a negative charge associated with that. How many more negative electrons than positive protons do I have? Well, 36 compared to 34 would be 2 more. So that's going to give me that -2 charge that I see here. Last piece, the number of neutrons. Well, how can I figure out the number of neutrons? Well, in order to figure out the number of neutrons, I have to recognize that it's the sum of the protons and the neutrons that give me that mass number. My total mass is 80. That's going to equal protons plus neutrons. So that mass of 80, if 34 of that comes from the protons, the rest of it needs to come from the neutrons. Well, 80 minus 34 would give me the 46 neutrons that I have in this specific isotope. So that's how we were able to get or fill in the rest of the table. What we also want to do is to be able to write this out in proper isotopic designation. So how are we going to do that? Well, we know the mass number sits in the upper left-hand corner. So that's 80 is our mass number. Our atomic number sits in the lower left-hand spot. That would be 34. The charge, whether you write -2 or 2 minus doesn't matter, sits in the upper right-hand portion. So the only thing we're missing here is figuring out which symbol we should use. So for this, we would look at the periodic table. Remember, the element's identity is based upon the atomic number, those number of protons. How many protons do we have? Well, our atomic number is 34. We would look at element number 34. Remember, you have to use the atomic number for identity. You cannot use mass numbers. Mass numbers do not give you identity. Because of different isotopes, different elements can have different masses. But what's really related to the identity is that atomic number, 34. So we would find element 34. We would see that it's selenium. So that symbol is Se. That's kind of how we could take part of the information, fill in the rest of the table, as well as write things out in their proper isotopic designation.